Hey there, Mr. Sutton here, bringing you the IM3 4.1 Extra Practice number 3 solutions on solving quadratics by factoring. There's a puzzle that goes with this thing. Let's go ahead and check out what that's about. For this puzzle, we're trying to solve the riddle of what is the title of this picture here. So the idea is we have a bunch of quadratic equations that we can solve all of them by factoring if we want. And once we've solved them, there's a list of solutions down below. Whatever the answer is, we just put that letter next to the number of the problem. For example, let's say I solve number 1, and I figure out that the answer is, I don't know, -2 and 5, -5. So I would put an I next to number 1 if that is actually the answer. I'm not sure if it is or not, but we're about to find out. Alrighty, here we go with problem number 1. On this problem and all the rest of them, we're going to factor the expression using whatever technique we need to, and then we're going to set each of the factors equal to 0 and solve for the variable. So that's our overall strategy. So for this one, since I just have a squared coefficient of 1, invisible 1 here, I just need to figure out two factors of 10 that add up to 7. 1 and 10 doesn't work, but 2 and 5 does if they're both positive. So I can actually split this up into a plus 2 and a plus 5. And then we just set each of those equal to 0. So if a plus 2 is 0, then a would be -2. And then to zero out a plus 5, I need to plug in -5 for a. So -2, -5, let me find that in my solution pool here. Looks like we've got that. It actually is I. I didn't even know that when I did the example at the beginning of this video, but hey, we got it. So that's what we're putting in number 1. And that's the only number 1 out of all of these. So that's fine. Some of these, though, appear more than once for the numbers, like 13, you see 2 of those. So we just have to be on the lookout for letters that get used twice. For problem number 2, again, we have a squared coefficient that's just 1. So all we have to do here is find factors of 12 that add up to -8. So 1 and 12, nope. 2 and 6, yeah, if they're both negative. So n minus 2 and n minus 6. Zeroing each of these out, we end up with n equals +2, because 2 minus 2 is 0, and +6. 2 and 6, that's C right there. So that means my 2 is going to get a C next to it. So here's a C for that one. And there's actually another 2 all the way over here getting a C as well. For this problem, I noticed that I have a difference of 2 perfect squares. So I can use my a squared minus b squared shortcut, where I square root each thing into a plus and minus parentheses. Square root of y squared is y. Square root of 49 is 7. So we have y plus 7 and y minus 7. Going back and solving each of these for 0, -7 plus 7 is 0, so there's one answer. And then +7 minus 7 would also give me 0. So I have 7 and -7, that's O right there. So we're doing that on spot number 3. Right there, and it looks like that's the only one. On this problem, I have a squared coefficient of 1, so I just need to find factors of -6 that add up to +5. Well, that would be -1 and +6, so I can write x minus 1 and x plus 6. Setting each of these equal to 0, 1 minus 1 is 0, so there's one answer, and -6 plus 6 gives me my other answer of -6. So 1 and -6, they wrote it as -6 and 1, same difference though. So we're getting a y in spot number 4, and it looks like there's only one of them, and there it is. This time around, I'm looking for factors of -18 that add up to -7. 1 and 18 doesn't work. 2 and 9 works. +2, -9. So we've got u plus 2, u minus 9. And then to zero each of these out, I need u equals -2 and +9, because 9 minus 9 is 0. And those two answers can be found right here under choice L. And this was number 5. So we're putting an L next to this 5, and the other 5 right next to it, actually. And double checking, it looks like that's it. For this problem, this one's actually a little bit faster than some of the others. There's just 2 terms, and we can take out a common factor of m. That leaves us with m minus 5. Zeroing each of those out, we get 0 for that m, because if we set m equal to 0, then m is 0. And then we can do 5 for the next one because 5 minus 5 is 0. So 0 and 5, that's going to be S, so we put an S next to the 6. On this next problem, I'm going to need to use the AC method. If I try taking out a common factor, that's not going to work for me here. So 2 times negative 3 gives an AC value of negative 6. So I'm looking for factors of negative 6 that add up to 5. Negative 1 and positive 6 would do it. So I can split this up into a negative 1t plus 6t. And now I'm going to use factoring by grouping since I've got 4 terms. First 2 terms I can take out a t, leaves me with 2t minus 1. For the next 2 I can take out a 3 from 6 and 3. That leaves me with 2t minus 1. Alright, so that 2t minus 1, that's a common factor that can come out. That leaves t plus 3 is my leftovers parentheses here. And then setting each of these equal to 0 and solving, for this first one I would have to add 1 and divide by 2, so that would be 1/2. Next one we subtract 3, so that would be negative 3 for that. So we got 1/2 and negative 3, that's choice J right here. So that's going to go under spot 7, right there. Alright, here's number 8. I'm looking to take a common factor out of here. It doesn't look like I'm going to be able to. 3, 8, and 4, nothing happening there. So AC method it is. 3 times 4 gives me the AC value of 12. So I need factors of 12 now that add up to negative 8. 1 and 12 won't work. 6 and 2 works if we have negative 2 and negative 6. So let's split this up into negative 2w minus 6w. And now I can use my grouping. First 2 terms I can take out a w, leaves me with 3w minus 2. And then the third term's negative, so I'll take a negative out of the next pair, negative 2 to be precise, leaving me with 3w minus 2. So now that 3w minus 2 is coming out, and then w minus 2 is our leftovers next to it. Setting each of these equal to 0, for this first parentheses I can add 2 and divide by 3 to get 2/3. And then for the next one, I just have to add 2, so w equals 2 for that. So 2/3 and 2, is that anywhere over here? Looks like it is, R. So that's going to be 8, and there's 8, and oh wait, there's another 8. So we get the R to go there twice. For number 9, this is another one where it looks like we're going to have to use AC method since no common factors can come out of here. So 2 times negative 5, that'll be negative 10. So factors of negative 10 that add up to negative 3. How about positive 2 and negative 5? That would do it. So we'll make this, instead of negative 3x, we will rewrite this as plus 2x minus 5x. And now using some grouping, for the first 2 terms, I can take out a 2x. That seems pretty clear there. So that leaves me with an x plus 1. For the next 2 terms, I can definitely take out a negative 5. Also leaves me with an x plus 1. So x plus 1 comes out of everything. 2x minus 5 is my leftovers next to that. And then zeroing each of these out, we have negative 1 plus 1 would give us 0, so that's one of our answers. And then setting 2x minus 5 equal to 0, I would add 5 and divide by 2. So 5 over 2 would be the other answer. All right, 5 over 2, negative 1. Where do I see that? All the way up here, choice B. And that's going under spot 9. So there's a 9 right there for B. And it looks like that's the only one. So on we go to problem number 10. For this problem, I feel like I ought to be able to take out a common factor with that 5 and that 20. That 29 is a deal breaker, though. No common factors out of all 3 numbers. So AC method, here we come. 5 times 20 is an AC value of 100, which I kind of like. There's lots of things I know that go into 100. So we need to pick 2 of them that also add up to 29. 1 and 100, nope. How about 2 and 50? Nope. 4 and 25, that adds up to 29. Positive both of them. So we'll make this, instead of 29v, that'll be a plus 4v plus 25v. Now I can use grouping. For the first 2 terms, all I can take out is a v. So that leaves 5v plus 4. And then for the next 2, I can take out a 5. That also leaves a 5v and a plus 4. So 5v plus 4 is coming out of everything. V plus 5 is my leftovers going next to it. Setting each of them equal to 0 and solving. For this first one, I would have to subtract 4 and divide by 5. So negative 4 over 5 for that answer. And then negative 5 zeroes out the next parentheses. Negative 4/5 and negative 5, that's going to be letter F right here. So 10 gets an F, and there's no other 10s out there, so on to the next question. All right, it's starting to get real. Last 4 questions. They've been teasing us up to this point, but you might notice that all the other questions have at least 2 blanks that you're going to get to fill in. That's why there's still so many that are blank. So this one, we can't use common factors. We'll have to use AC method. 6 times 15 gives us AC value of positive 90. So we need things that multiply to 90 and add up to 19. 1 and 90, 2 and 45, 3 and 30. None of this is working. 4 and... Oh, 4 doesn't go into 90 actually. How about 5? 5 and 18. That's getting us closer. Still not quite what we need. 6 goes into 90 15 times. Still not going to get us to 19. What else? How about 9 and 10? Yeah, negative 9, negative 10. That'd do it. So we'll split this up into negative 9n minus 10n. There we go. For my first 2 now, using grouping, I can take out a 3 and an n. So that leaves me with a 2n for that first one, and then minus 3. For the next 2 terms, I'm going to take out negative 5 because that third term is negative. So that leaves me with a positive 2n minus 3. 2n minus 3 comes out. 3n minus 5 goes in to our common factor, or our leftovers parentheses rather. And now zeroing each of these out, first parentheses, if I add 3 and divide by 2, I've got 3 halves. And then for the next one, if I add 5 and divide by 3, I have 5 over 3. 3 halves, 5 thirds. Where do I find that? Down here, this is going to be A. So 11 then, here's an 11, this gets an A, and this gets an A down here. Number 12, you might be doing a double take because you've been doing a whole bunch of long-winded AC method sort of problems. And this one, I mean, it can't be that easy, but it is. We just have to take out a common factor of k. That leaves 2k plus 7. K equals 0. That's one of our equations we can set up. And then if 2k plus 7 equals 0, subtracting 7, dividing by 2, we get negative 7 over positive 2. So we need 0 and negative 7 halves. That's an E, and we get to put that in spot number 12. So there's an E for that 12. Let's see, here's another 12. This gets an E. And we actually have a third one rather, over here gets another E. So we got a lot of mileage out of that one problem. Well, I hope you enjoyed the last problem because we're back to needing AC method. This time around we've got 3 times negative 10, that's negative 30 for AC. Now we need factors of negative 30 that add up to 1. We have an invisible 1 there. So 1 and 30 doesn't work, 2 and 15 won't, 3 and 10 doesn't work, 5 and 6 works, negative 5, positive 6. So we'll make this negative 5b and then positive 6b. On to grouping. For the first 2 terms, I'll take out a b, leaves me with 3 minus 5. For the next group, I'll take out a 2. That's also going to be 3b minus 5. 3b minus 5 is our common factor that we can pull out. B plus 2 is the other factor then. Setting each of these equal to 0. For the first factor, we can add 5 and divide by 3. That's going to be 5 thirds. And then we can subtract 2 to get negative 2 for the other b value. So those 2 are up here with choice n. That's going to be number 13. So we have an n going here, right next door to here, and I believe that is it. No more 13s. Everything else is 14. For our final boss battle problem, you could use AC method on this one, but it's kind of overkill. You might notice these are both perfect squares. So we can use our a squared minus b squared shortcut here. There's no common factors to take out either, so we can just go straight to the shortcut. Square root of 4y squared is 2y. Square root of 25 is 5, so 2y plus 5. and 2y minus 5. Setting each equal to 0 and solving, for this first one, we subtract 5 and divide by 2, so that's negative 5 over 2. Next one, we're adding 5 and dividing by 2 for positive 5 halves. And those answers can be found, where are they? Here they are. I was looking for them. T, letter T. So that's what 14 is. So we have a T here, we have another T right below, and the final T at the very end here. And I've filled in all the letters, so now I can go ahead and solve the puzzle. So the puzzle again was asking the question, what is the title of this weird looking picture? So just reading through here, we've got, let's see, T-E-N, that's 10, but there's a little bit more here. Tennis. So that's a sport. And then B-A-L-L, obviously that's ball. So tennis ball, that makes sense. And then this looks like factory that they wrote next. That's pretty distinctive. And then finally we have reject. So this is a tennis ball factory reject. I guess I could see that. Till next time, this is Mr. Sutton signing off.